Creepy crawly Jew or insect Jew is a red Goliath star. In the event that you put it where the sun is, it would stretch out to the orbit of Jupiter, huge, entirely unsteady, and about to detonate. They are among the greatest blasts of radio energy in the whole universe, creating more energy than a billion suns. Scarab Jew or insect Jew is a red monster star. On the off chance that you put it where the sun is, it would reach out to the orbit of Jupiter, colossal, truly temperamental, and about to detonate. When we consider stars, we probably envision little sparkling things in the evening sky. Essentially, this is the way we see them from down here on Earth. Yet stars are something totally different. In fact, one of the greatest stars, Betelgeuse, happens to be a lot bigger than our sun. For quite a long time, this star has puzzled researchers. However, recently, something more agitating has been occurring with creepy crawly Jew, making researchers and other well-informed people extremely concerned. Join us in this video as we explore the staggering news about Betelgeuse, its approaching obliteration as predicted by the James Webb Space Telescope, and how this new development will influence our universe and our lives here on Earth. As explained by physicist Michio Kaku, Betelgeuse is an infinite marvel, a huge star that has charmed cosmologists for so long. A Greek astronomer named Tony was quick to discover it. This star is gigantic to such an extent that it can be seen in the night sky from Earth, especially during winter. If you're into constellations, you've likely seen or heard of this star. It is the ruddy orange star that marks the upper left shoulder of the Orion constellation. So, you see, this star is old and, so far, one of the most brilliant stars in the night sky. Yet one thing about Betelgeuse's brilliance is that it doesn't remain steady. Rather, it fluctuates. This change is one of the unique properties of the star, but it isn't the only one. Let's take a look at some of Betelgeuse's specific properties. Most of the stars you find in the evening sky are far from Earth. The closest star is 4.2 light-years away from Earth. If you fail to understand how the term light-years explains distance, picture it this way. Consider traveling at the speed of light for an entire year. It has been demonstrated that light can cover a distance of 186,000 miles per second. Thus, the distance light can cover in a year is equivalent to 1 light-year. If you do the math, you'll get billions of miles. So, when we say the nearest star is 4.2 light-years away, it means it is billions of miles from Earth. However, some stars are significantly farther, and Insect Jew is one of them. Insect Jew is located roughly 600 light-years away from Earth. So, if you were to travel to it at the speed of light, it would still take 600 years. We can't travel that fast, not even our fastest spacecraft can. Yet this star can still shine so brilliantly in our sky. If you're wondering how Insect Jew can be so bright despite its distance, that is due to its various characteristics like size and luminosity. Creepy crawly Jew is around 500 times bigger than our sun. Its radius is believed to be multiple times that of the sun. Unfortunately, it appears as a disk in space while using complex telescopes, while other stars appear as tiny points of light. This appearance is thought to be an effect of the reactions at the outer layers of its atmosphere. Regarding mass, Betelgeuse measures around 12 to 19 solar masses. A solar mass is the standard unit of mass used by astronomers. One solar mass is equivalent to 2 times 10 to the power of 30 kg. Researchers can't determine the exact mass of Betelgeuse since there are no other planetary bodies orbiting around it to compare, and obviously we can't measure it directly from here. The fact that this makes it visible on Earth is remarkable, but the star is no less than 12 times heavier than our sun. The luminosity of Betelgeuse ranges from magnitude +0 to +1.6. In more familiar terms, Betelgeuse is about 100,000 times more luminous than our sun. No wonder it was nicknamed a red Goliath. Anyway, the luminosity of Betelgeuse doesn't remain steady. It fluctuates. This fluctuation is due to its pulsations. In other words, Betelgeuse expands and contracts. When it expands, it becomes brighter. However, when it contracts, it dims. This process can last from 10 to 100 days or even longer. One unique property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field in these regions is far stronger than at the average surface. However, the drawback is that these strong magnetic spots inhibit the flow of hot gas to the star's outer surface, making the star cooler in these areas. The fact that Betelgeuse has many more of these spots compared to our Sun explains why it is cooler than our Sun despite its size and brightness. The Sun also has its own dark magnetic spots, but those on Betelgeuse are much larger and more numerous. To give you an idea, the spots on Betelgeuse can be twice as large as Earth. Betelgeuse also boasts a magnetic field that is 100 times stronger than that of the Sun. This field is why, when seen through a telescope, the gases on the surface of Betelgeuse appear to be in loops or arcs. Betelgeuse has a surface temperature of around 3,500 K. This low temperature contributes to the low energy radiated by the star and its faint red color. Betelgeuse is a red star, but it wasn't always red. It was yellowish around 100,000 years ago, like our Sun. Over time, its color started changing to orange-red, and then, around 100,000 years ago, it slowly began turning into the red star we know today. This fact has led researchers to believe that the star is aging. Betelgeuse radiates as much as 100,000 times more energy than the Sun. It would have been a fierce competitor to Earth's Sun if it weren't so far away. The fact that Betelgeuse, which is 600 light-years away, can still be seen and identified with the naked eye at night is quite remarkable. Our Sun is only 8.3 light-minutes away from Earth. That is why it's so bright. If Betelgeuse were just a little closer, we would also be able to see it during the daytime. But if it were to replace the Sun, it would engulf or displace Earth and the other 4 planets close to it due to its immense size. Moreover, even if it could match the Sun's brightness, it radiates more radiation than our Sun. Betelgeuse, also known as Insect Jew, is a very Goliath star located in the constellation Orion, roughly 600 light-years from Earth. Its massive size is one of its most striking features. It is around 1,000 times bigger than our Sun in terms of diameter and could easily encompass the orbit of Jupiter if placed at the center of our solar system. This titanic size allows Betelgeuse to appear as a distinct disk rather than a point of light when viewed through powerful telescopes. In contrast to most other stars, despite its colossal size, Betelgeuse is not the most massive star. It ranges in mass from about 12 to 20 times that of the Sun. This variation in mass estimation is due to the difficulties in accurately measuring the mass of stars that lack a companion star or other objects to provide gravitational reference points. Nonetheless, even at its lower estimated mass, Betelgeuse remains a significant celestial object. The luminosity of Betelgeuse is another important characteristic. It varies regularly over time, with its brightness ranging from magnitude +0 to +1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude +1 star. At its brightest, Betelgeuse can be up to 100,000 times brighter than our Sun. This fluctuation is attributed to its pulsations, periodic expansions and contractions caused by internal processes within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These pulsations can last from days to months, contributing to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a large star, measuring around 3,500 K. This gives it a distinct reddish-orange hue typical of red giants. Stars approaching the end of their life cycle, like other red giants, are in the late stages of stellar evolution. Betelgeuse has depleted the hydrogen fuel in its core and started fusing heavier elements. This fusion process generates energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena and shows dark magnetic spots on its surface, which are significantly larger and more numerous than those found on our Sun. These spots are regions of intense magnetic activity that inhibit the flow of hot gases from deeper within the star to its surface, contributing to cooler spots on the star's surface. Betelgeuse's history and cultural significance also make it a notable celestial object. Known since ancient times, Betelgeuse has been observed and documented by various civilizations for centuries. Its visibility in the night sky, especially during winter in the northern hemisphere, has made it a prominent feature in star constellations and mythology. In recent years, Betelgeuse has gained renewed attention due to its potential for a dramatic stellar event. The James Webb Space Telescope has provided new insights into the star's behavior, raising concerns about its potential to undergo a supernova explosion in the near future.